This is MAC 1105, Section 1.4, Part 2. In Part 1, we learned about what is a complex number, what is an imaginary number. We added and subtracted, and we also multiplied complex numbers. Now we're getting ready to talk about division of complex numbers. And it's really not so much division, it is a matter of simplifying these fractions. And of course, a fraction is indicated division. That's why we call this division of complex numbers. We are going to need this complex conjugate idea in a minute, but let's go back a second. You should remember that you cannot have a radical in the denominator of a fraction. Cannot have a radical in the denominator of a fraction. So what we did back then, when this was a monomial, we just multiplied top and bottom by that monomial, which gives me 5 radical 2. Radical 2 times radical 2 is 2. So we have cleaned this up a little bit so that there is no radical in the denominator. You might look at this and say, hey, I don't have a radical in the denominator, but you do, because remember that I stands for the square root of -1. So we do have a radical in the denominator. You might look at this and think, oh, let's just multiply top and bottom by I. Well, if I just look at the bottom, 3 times I is 3I, and 7I times I is 7I squared. And yes, I could cross that out and change that sign, but I still have an imaginary in the denominator, which I can't have. So one of these that has a binomial denominator, you are not going to get rid of the radical by multiplying by a monomial. The only way to clear this I out of the denominator is to multiply by the conjugate. The conjugate of 3 plus 7I is 3 minus 7I on the top and the bottom. By multiplying by the same thing on the top and bottom, all you're really multiplying by is 1, which does not change the value of anything. So now I can put these in parentheses, take any of the binomials you have and put them in parentheses. On the top, we're going to distribute 4i times 3 is 12i. 4i times -7i is 28i squared. I'll come back and clean that up in a minute. The bottom is going to be easy arithmetic because we devised this to be the conjugates, and I can just do 3 times 3 is 9, minus 7i times 7i is 49i squared. Now let's take care of the I squareds. Cross out I squared, change the sign, cross out I squared, change the sign. Now I still have some work to do here. Number one, on the top, I've got to rewrite that so that the I is in the back side. And on the bottom here, I have 9 plus 49, which is 58, which looks like a decent answer, but the problem is this has got to be in standard form. That's not standard form. Standard form is A plus BI. So I need to separate this out to 28 over 58 plus 12 over 58i. So now I do have an A, which is 28 over 58, and I do have a B, which is 12 over 58 times I. The only thing is I have to reduce both of those. 28 over 58 is going to reduce by 2 to give me 14 over 29, plus I can reduce by 2 here also, which is 6 over 29i. So that is my answer. It is in standard form, and it's okay for the A and the B to be fractions. So same process over here. We're going to multiply by the conjugate, which is 5 minus I. That's the only way you're going to get rid of the imaginary. Put all of your binomials in parentheses. That just helps you out with your arithmetic, whether you are distributing or using FOIL. So distribute through the top is 40 minus 8i. The bottom, 5 times 5 is 25, minus I squared. Now be careful with something. Remember, I kept saying you want to look at the I squared, cross it out, and change the coefficients sign. Well, what coefficient is in front of I squared? 1. So when I cross this out and change that sign, the bottom becomes 26. 25 plus 1 is 26. The top is already in standard form, but I still have the situation where I need to separate this out. So 40 over 26 minus 8 over 26i, and then reduce. And remember, if you're not very good at reducing on your own, type it in your graphing calculator, and that reduces. So I can reduce this by 2, which gives me 20 over 13, minus, reduce this by 2, 4 over 13 times I. And that is your answer in standard form. Now both of those happen to have a monomial in the numerator. This was 4I, this was 8. It's a little more complicated if you have a binomial to deal with. I still need to get rid of that I in the denominator by multiplying by the conjugate. So this is 2 plus 5I, and this is also 2 plus 5I. Be sure you are multiplying top and bottom by the same value. These are all a bunch of binomials, so I will put them in parentheses. And then I'm going to have to think about FOILing up here on the top. Let's move this out of the way for right now. Oops. So FOIL on the top, 7 times 2 is 14, plus 35I, plus 8I, plus 20I squared. The bottom is simple, 2 times 2 is 4, minus 25I squared. So let's get things cleaned up. Cross off the I squared, change the sign. So I've got 14 minus 20 is negative 6, plus 35I plus 8I is 43I. And on the bottom here, cross off the I squared, change the sign, gives me a 29. I still need to separate these out. So this is negative 6 over 29 plus 43 over 29I. That is your answer in standard form. So this one, multiply by the conjugate. And remember, the conjugate is just a matter of changing the middle sign. This is still negative 4. This is negative 4 plus I, negative 4 plus I. And put everything in parentheses. And then FOIL. So 5 times negative 4 is negative 20. 5 times I is 5I. 4I times negative 4 is negative 16I, and 4I times I is plus 4I squared. We'll clean it up in a minute. Then the bottom, negative 4 times negative 4 is positive 16 minus I squared, which is really minus 1I squared. Take care of the I squared, cross off I squared, change the sign. So that's a negative 20 minus 4 is negative 24. And the bottom is 5I minus 16I is minus 11I. Down here on the bottom, cross off the I squared, change the sign, gives me 17. So I just have to separate this out. And that is my answer in standard form.